Hello everyone, I'm Xiao Gang. If you're using a slightly newer version, take a look at which version I'm using. This is the demo we wrote earlier. We need to look at the uproject. If it's version 5.1, it seems to be directly integrated into this location. We can see in this plugin, and then we type ControlFlow here, which is this plugin. This tool can very cleanly implement this kind of asynchronous operation. So where does this plot come from? Actually, it comes from here. We can see in the Lyra project, there is also a plugin called ControlFlow. It might not be here anymore. Possibly, yes. But it actually uses this plugin. Yes, it means that as a reference for a commercial project, it replaces this part. Yes, the knowledge in this chapter might be a bit difficult, and it's not possible to explain it in too much detail, because when it's actually used in a project, only then can we truly right now. We are just simulating. Okay, you can see here we can input, right, create a counter. Let me take a look here. These are modules. Yes, it has already. It should have no plugins, but actually it used to appear in plugins. We can search for it. ControlFlow. Found it. Here you can see there is a plugin called ControlFlows. Then within this plugin, what is it mainly used for? You can see here. It has a function that, after the level is loaded, it initializes some user information. Then the screen. Then it establishes the drawing, and finally displays the main screen. This is a typical application of it, a scenario. We are mainly referencing these as well. These articles on Jihe and this engineering capability, let me show you how it is used. Then, let's first take a look at the effect of using it. This is our previous button. I just placed it. It is essentially in our after it starts. After it starts, there will be a UI. We can ignore this UI for now. This UI has a progress update. You can take a look. It should be written in the game mode. Let's check. It should be in the HUD. You can see this part is in the game mode. We bound two events. The initialization result and the progress update. This dynamic multi-wave, right? Then after you bind them, our C++ layer will send you the information. If it succeeds, we will remove this UI. If it fails, we will print this initialization failure. And we can see here, after we start it, we can ignore this if it's not fully covered. This is the UI. Everyone can improve it later. Then it starts to progress in that place. So this place is initializing. First, initialize the local assets. Then initialize the network information. Then here, we assume there are 10 pieces of network information. We have already initialized them. Then initialize some other information. Then update our menu. Finally, it is completed. So this is an initialization. That's not right. Then if it fails, you can see if we force it to fail here, we change this to false here. If we assume the 6th task fails, let's see if we can listen for the task failure. Okay. On our end, we can see. You can see it starts executing again here. Then at this point, it starts selling along information. Then we know the 6th task will fail. You can see this task has already failed. False. Because it's due to this move failure, it keeps getting stuck here. It just stops moving because we haven't written any other logic. Then at this point, you could actually pop up a window or directly force close the application. But closing the application might not be very user-friendly. Maybe just to pop up a window. The user checks the network connection or updates the account password or some information like that. Right, okay. Actually, as for this ControlFlow, we'll stop the demonstration here. Let's first take a look at the code. And then we'll write it together with everyone. This part is actually written in. Oh, I wrote this. Here, there are two dynamic multi-dials, right? And because it's dynamic. That's why it's called dynamic. This place, because it doesn't have dynamic at the C++ level. So it doesn't have dynamic. And this is our simulation task. So the simulation task, we made a management task. Then suppose we have a task to initiate multiple asynchronous tasks. We listen, and this is what's it called? A shared pointer. You see, we made the task into a shared pointer because this task might need to exist in the form of a shared pointer. Because this task, it may have a lot of data. We don't want to, when copying, keep copying all this data back and forth. That would be quite performance intensive. Then here, we use an enum to determine the status of this task. Then we go back to our gamble base. So here, it mainly goes through this section. In this section, we declare the task flow. In this task flow, it's actually our ABCD, right? After declaring it here, we just let it start executing. Then in each of these bound functions, actually, these are all on the main thread. This place is where these asynchronous threads are truly initiated. To execute this task, after it's done, this place can make a return to the main thread, telling the main thread when to do it. And in this place is this arrow. The arrow coming back. This place is an arrow going out. This is like a going out. And then this is A coming back. And then this is equivalent to B going out and then B coming back. So this B comes back. This B might have done 10 tasks from B to B10. So we just force a certain task to fail. It could be something like task B6 failing. Okay, let's stop here for now. We'll stop here for now. Next, we'll guide you through writing it.